Good morning, everyone. Sorry that I can't be with you today. I am out sick. Hopefully, I'll be back tomorrow, but we'll see what happens after I go to the doctor. Today, you're going to be taking notes on 5.5 and then working on the practice. Okay. Now, if you're in my first period class, you've already done some of the notes. For third period, this will be all new to you, so make sure to pay attention. Our learning target today is that we're going to be writing exponential functions from real-world scenarios. We need to be able to identify the a value, which is the y-intercept, or initial value, the b value, which stands for the growth or decay rate, and then we need to be able to plug them into the equation. So let's remember what the equation actually is. So the exponential equation is y equals a times b to the x power. The a, the very first number you write in your equation, is the y-intercept. But in real-world scenarios, we are not looking at a graph usually. So we also need to know that it also stands for the initial value. Like maybe you started with a population of 1 million people, or maybe you started with $500. It's however much you're starting with, your initial value or amount. The b value is your growth or decay rate. A few things to remember from what we learned in the last couple lessons is when is it growth and when is it decay. If our b value is greater than 1, so remember that's greater. If you don't know what that symbol is, it's a greater symbol. If b is greater than 1, then it is a growth. Okay? So some examples of that would be 2, 3.8, or even a fraction, an improper fraction like 7/4. Because 7/4 is really just 1.75. So if it's an improper fraction where the numerator is larger, it's actually a value bigger than 1. So it is a growth. You could always type fractions in your calculator to see if it's bigger than 1 or less than 1. Now, if we have a b value between 0 and 1, it is a decay. So that could be numbers like 0.75 or 1/3 or 3/4. All of those are not improper fractions. 1/3 is 0.3 repeating, 3/4 is 0.75. They are all values that are less than 1 but bigger than 0. We will not have any negatives. No b values are negative. No negative b values. Okay, very important to note. There will never be a negative b value. Okay, it's either bigger than 1 or between 0 and 1. So let's look at our first example. Our first example is the following. This year, the number of students who participated in sports was 317. Each year, the number of students who participate increases by 4%. Increases tells us this is a growth. Okay, very important to note. And this is how many we started with, our initial value. So we already know part of our equation is 317. Now the question is, what is the growth rate? I will tell you this, it is not 4. We are increasing by 4%, and usually this is where people make small errors. So we always start with 100% of anything. We start with 100% of the students that are participating in sports, and we're increasing, so adding 4% to it. When we add them together, we get 104%. And all we have to do, and I know it's been a while since you were in elementary or middle school and you had to convert a percent to a decimal, here's how you do it. You put your decimal point after the last number and move it 2 places to the left. So 1.04, that is our rate. Okay, this is the b value, 1.04. And you can see it is a growth because it is larger than 1, right? But it only grew by 4%. So you're not putting 4 as the b value, you're adding it on to 100%. So our equation then, remember the formula, here's the formula on the right side. Y equals, and whatever you started with goes first. We started with 317 students that were participating in sports. And then you put your growth rate, 1.04, in the parentheses raised to the x power. And there's the equation. Now, there is one similar right next to it, example 3. Try example 3 on your own. Pause the video and then give it a try and then see if you are correct. So looking at this problem, you can see I've highlighted initially we had 1,200,000 elephants. So I wrote that down as my A value, how many we started with, the elephant population. Then it decreased. So instead of adding like in example 1, we are subtracting. And we still start with 100% and we minus 6.8% and we get 93.2%. Then we still move the decimal 2 places to the left. So our B value is 0.93 or 0.932. Okay, so you could put the 0 in front like I did in the equation, or you don't have to. But notice it is less than 1. That's important to note. Decay should be less than 1, and it is because we subtracted the 6.8%. So to remind you, I subtracted the 6.8% and got 93.2%, moved the decimal 2 places to the left, and got 0.932, which is our B value, our rate. Okay. All right, let's go ahead and look at example 2. Now these were actual STAR questions, so let's have a look at them together. This one I believe was on the STAR test just last year. Researchers were studying the population of a town over time, and they modeled data using an exponential function. They gave us some very important information right here. It says the initial estimated population was 48,000. So remember, that's the A value in your equation. And in our equation, the A value is what goes first. Okay? So our first number should be 48,000. So it's either A or D. So I'm going to go ahead and mark out B and C. I know they're incorrect. Okay? And it says after the first year, the population of the town was 50,400. So this one actually didn't give you a percent that you were increasing or decreasing by. We can tell it was increasing though, but making a table really helps. We initially, so 0 time has passed, we initially had 48,000. But after 1 year, we now have 50,400. So see, I made a table. Initial means no time has passed. X is the number of years, and Y is what the population was. So remember, to find rate, we've talked about it. Take the second Y value and divide it by the first. So our rate would be 50,400. The second value divided by 48,000. And you don't have to type it in your calculator because look, they left it exactly like you see it. Okay? So A is the correct answer. You could also note that if you typed those two fractions in the calculator for answer choices A and D, that A would give you a growth. But if you're looking down here at 1 over 50,400, if you type that in the calculator, that's going to be a value less than 1, and it's a decay. And as we can tell, our population is growing. Okay. All right, guys, let's look at this last one. And this one's slightly different, and we're going to need our Desmos calculator for this because we are dealing with data, which is never beautiful and pretty. Keep that in mind. So the table below shows the net revenue in millions of dollars of a company every 3 months for 2 years. An exponential function can be used to model the data. Write a function that best models the data. Notice I even wrote round to the hundredths place. So let's go ahead and start by typing our data into Desmos. So take a moment, pause the video, pull up your Desmos graphing calculator, and type in this table. As you can see on my Desmos graphing calculator, I've typed in the table. Yes, you need to type in every single point because this is data and we need to use every data point. It's not going to be in a beautiful, pretty exponential curve. Okay. Real world data is not perfect. And that's why we're going to get decimals that we're going to have to round. Um, I zoomed out so that you could see the points on my graph. Now to get the equation, the A and the B value, remember, go to the second line, type Y1, and then the squiggle, which is right next to the number 1 on your keyboard, A, B. Now, a lot of people forget this part, how to make an exponent. So hit Shift 6 to make an exponent, or you could hit your keyboard. Shift 6 is probably the best thing to type. And then write X1. Okay. Now, please note it is very important that you hit the button that says log mode. Okay, especially for real world data. So just get used to clicking it because look, it does change the A and the B a lot. So make sure you're hitting the log mode button. It needs to be checked, okay? Now here we have our A value and our B value. So go ahead and take a moment to write down your A and B value and write the equation for that last problem. Notice that I did round to the hundredths place, which is 2 places after the decimal. On the STAR test, they typically round to 2 places after the decimal. My A value was 223.06, and the B, which is a growth, is 1.09. You'll notice it's bigger than 1, right? And we can tell that it's growing because if you look at the table, you can see over time the revenue is increasing. Okay, there's the equation. So remember, anytime you're given a table, you can put it in, and you do have the directions right here on how to type it in to the Desmos graphing calculator. So take some time now to work on the 5.5 practice. I am sorry, it should say 5.5 like mine does here, but the copy you received probably says 5.6. There was a typo. Sorry about that. But this is the practice you need to work on it. You'll know because Dory is over here in the corner. Work on it today. Please turn it in by the end of the period, whether you are done or not. Please turn it in. Okay. And then I'll look to see how you did when I come back. Thank you so much, guys. Have a great day.